what are called similar triangles. This is the second page of the class task box. When we have two triangles in which the three interior angles are congruent, that's called similar triangles. And that means that we can do a little math, right? So for instance, if you have two triangles, one may be bigger than the other. And if the angles all match, then we can do some math based upon ratio. So I'm just drawing two diagrams that have the angles match. So this is what we mean by A and B. These triangles are not guaranteed to be congruent, but they're still related mathematically. So for instance, let's say this triangle, we have all the sides known. This triangle is one that's bigger, only the bottom side is known. So the other two sides, we don't. Well, we can use ratios. If two triangles have the same three angles, then the ratios of the corresponding sides are always the same. So the two left sides is a ratio, the two bottom sides is a ratio, and the two right sides is a ratio. Those are called corresponding side ratios. Okay, you want to draw the picture of your triangles where the angles all match. That way it's much easier to visualize how to create the ratio. So we can solve for x, 5 over x, and then on the bottom side, 10 over 25. Solve that problem. And what do we mean by adjacent side ratio? Adjacent side ratios mean you're going to write the ratio based upon the connection to the same angle. So if we wanted to solve for y, we could write the ratio connecting the three angles. This would be what we call adjacent side ratios. Okay, so 7 over 10 equals y over 25. That's also something valid. You could also do corresponding. So you could have did 7 over y equals 10 over 25. That would have been okay. All right, and then at this point, just cross multiply. So 10x equals 5 times 25. And you divide by 10. Okay, so whereas over here, again, cross multiplying, 10y equals 7 times 25, and then you divide by 10. So when you draw your two diagrams, match the angles. That way it's easier to see. Adjacent corresponding sides, 5 over x, 10 over 25. Those are equal. If you want to do adjacent sides, then you do the ratios based upon connecting to the same angle. So connecting to the 3 angle, 7 over 10, y over 25, and then you can solve this, which is just a matter of cross multiplying. Now, another way to think about this. One of these triangles is bigger than the other. So if we could think of what number do we multiply to the 5, 7, and 10, that'll be okay. We could figure out how could we multiply to these three numbers to get the bigger triangle. Okay, so let's say we multiplied that by some number we don't know. This is called a scale factor. And sometimes this is helpful. Okay, so what did we multiply to the 10 to get the 25. Since we know the two bottom sides, we might as well figure out the scale factor by doing times, what times 10 equals 25. Right? We don't know the two left and right sides here, so we can't get the scale factor by using the two left and right sides. We're going to have to do the bottom side since those two sides have numbers. All right, so what did we multiply the left triangle to get the right triangle? Okay, so then in this case, it would be 2.5. So the larger triangle is 2.5 times bigger than the smaller triangle. All right, and that's another way you could solve these problems. That might be easier sometimes. So to get the x, multiply the 5 by 2.5. To get the y, multiply the 7 by 2.5. That'll work. And depending on the situation, that actually might be easier. And that's called the scale factor.